Okay, so here's another example of what we would use integration by parts. So here we have an exponential with this algebraic form. So we have the algebraic function times an exponential function. Okay, so let's look at this and see what we should do. Okay, so again, we want to choose our u and we want to choose our dv in such a way that we can easily integrate the dv and we can differentiate the u. Okay? And we want to make sure that we get something, when we do this, we get another integral. We end up with an integral that's easier to handle. Okay. So, in this case here, we can integrate this, okay? And if we integrate this piece, it gets more complicated. So we don't want that. So we'll integrate, and this piece can be integrated, and at least it won't get more complicated looking. You know, pretty much looks like it's going to stay the same, right? E to the x always ends up with an e to the x. So let's integrate this and differentiate this, because if we differentiate this piece, we get something simpler, okay? 1. So, let u equal x and dv equal e to the 2x dx. And so that means du is going to equal dx. And here we're going to integrate, so we're going to get v equals what? Well, remember how to integrate exponential functions with the e, right? The natural exponential. So this is going to be what? It's going to be the e to the 2x, but times the derivative of the inside function, right? So in this case here, we're going to get the derivative here is going to be 2. So we get 2 oh, I'm sorry, hold on. We divide by the derivative of the inside function. Okay? And if you see that, just take the derivative of this, right? If we take the derivative of this, it's e to the 2x times the derivative of the inside function, which is 2, and you get back to where you started with. So that is what we're going to use. So now that we got our choices, let's substitute in. And so again, it's going to be u v minus the integral of v du, which in this case is going to be now x 1/2 e to the 2x, okay, minus the integral of v and then du, which is just dx. And so now we got something we can integrate. So now what do we get? We get, well, this is going to become 1/2 x e to the 2x minus, now we're going to integrate this. Now we're going to do it again, so this is going to become 1/4 e to the 2x plus c. Okay? And that's it. Easy peasy. Now, how do we choose our values? Okay, so how do we choose what is u and what is dv? And to be honest with you, it comes with trial and error. Okay, but there is an acronym and a little mnemonic you can use to help you decide what you're going to make u. Okay, and what is going to end up being your dV. And you can use this acronym LIATE or LIATE or LIATE or LIATE, whatever you want to pronounce it, but it's LITE. So L stands for logarithmic functions, I is inverse trigonometric functions, A is algebraic functions, T is trigonometric functions, and E is exponential functions. Okay, so this is the order in which you want to assign how you want to assign your u. So for example, if you have a logarithmic function matched up with an algebraic function, then the logarithmic function you want to be u, and you want to let your algebraic function be dv. Okay, so you want to choose something that is going to be easy to integrate, right? And you're going to end up with something similar, or simpler, I should say. Okay. So again, it's just trial and error. So for an example, in the one that we did earlier, x sine x, right? Algebraic and trigonometric, since a comes before t, we want a to be the u and sine x to be the dv. Here we have an exponential and an algebraic. Algebraic comes before exponential, so this is our u, this is our dv. Okay, so that'll give you some idea of how to choose what to be your u, what to be your dv. Now, here with the log and the inverse trigonometric function, we could have switched these, because you won't ever find a logarithmic function and an inverse trigonometric function in a integration by parts problem. Likewise, these we could have switched around to, because it really doesn't matter if you have a trig function and exponential, which one you choose to be your u and v, they're pretty much the same. And then these are in the middle because they're pretty much the same. Okay, so again, what else can I say about that? And algebraic functions are pretty much easy to integrate or differentiate, so that's why they pretty much come in the middle. But that's it. So again, here's just a way, but again, I always look at ways of how am I going to make this simpler, okay, because that's the goal. You don't want to end up with something more complicated. Have a great day.